Space is vast. It stretches out in all directions, an endless ocean of darkness and mystery. It is a canvas of darkness, sprinkled with the faint glow of distant stars, each one a distant sun, a beacon of light in the infinite void. In this apparent emptiness, something incredible is about to occur. The silence of space is deceptive, for it hides the most dramatic events in the universe. Two celestial objects, invisible to the naked eye, are on a collision course. They move silently through the void, drawn together by the invisible hand of gravity. They are neutron stars, the remnants of massive stars that have lived and died. These dense, compact objects are the cores left behind after a supernova explosion. Their journey has brought them to this desolate region of space, far from any galaxy's warm embrace. Here in the cold and dark, they continue their silent dance. The space between galaxies is a lonely place. It is a vast expanse where the light of stars is faint and the presence of matter is scarce. It is devoid of the gas and dust that give birth to stars. In this barren region, the usual processes of star formation are absent, yet in this emptiness, a cosmic drama is about to unfold. The universe, in its infinite expanse, is never truly still. The two neutron stars, drawn together by an inexorable force, are about to collide. Their meeting will be brief but cataclysmic. The result will be one of the most powerful explosions in the universe, a kilonova. This explosion will release an immense amount of energy, outshining entire galaxies for a brief moment. The aftermath of this collision will scatter elements like gold and platinum into space, seeding the cosmos with the building blocks of future stars and planets. And so, in the vast, silent void between galaxies, the cycle of creation and destruction continues, a testament to the dynamic and ever-changing nature of the universe. Imagine a collision so violent that it momentarily outshines entire galaxies. That's a kilonova, a cosmic event so rare and powerful that it captures the imagination of astronomers and scientists alike. It is a cosmic explosion of unimaginable power, a testament to the extreme physics at play in the universe. The sheer energy released in a kilonova is beyond comprehension, dwarfing even the most powerful supernovae. It is the universe's ultimate fireworks display. When two neutron stars collide, they merge in a fiery inferno. These neutron stars are incredibly dense remnants of massive stars that have already gone supernova. Their collision is a cataclysmic event, one that has been billions of years in the making. The sheer force of their impact is enough to warp the very fabric of space-time. This cataclysm releases a burst of energy that ripples across the cosmos. The shockwaves from the collision can be detected across vast distances, providing valuable data to scientists studying the universe. It's like a cosmic beacon, signaling the birth of something extraordinary. But a kilonova is more than just an explosion. It is a transformative event that reshapes the very fabric of space and time. It is a cosmic crucible where the universe forges its most precious elements. It is a cosmic alchemy lab. In the intense heat and pressure of the merger, atoms are smashed together, forging new elements. This process, known as nucleosynthesis, creates elements that are heavier than iron, which cannot be formed in regular stellar processes. It's the universe's way of creating its own treasure. In the intense heat and pressure of the merger, atoms are smashed together, forging new elements. These elements include gold, platinum, and other precious metals, which are scattered throughout the universe. These are the building blocks of planets, stars, and even life itself. These elements, some of the heaviest in the universe, are blasted out into space. They travel across the cosmos, seeding new star systems and contributing to the formation of planets. It's a cosmic distribution of wealth. They will eventually become the building blocks of planets, stars, and even life itself. The elements forged in the heart of a kilonova are essential to the creation of the universe as we know it, making these rare events crucial to our understanding of the cosmic evolution. In the grand tapestry of the cosmos, kilonovas are the master weavers, stitching together the very fabric of existence. Neutron stars are the remnants of massive stars that have gone supernova. When these stars exhaust their nuclear fuel, they can no longer support themselves against their own gravity. The core collapses, and the outer layers of the star are ejected in a spectacular explosion. What remains is a neutron star, an object so dense that a teaspoonful would weigh billions of tons. Neutron stars are incredibly small, only a few miles across, but they are also incredibly hot, with surface temperatures of millions of degrees. Some neutron stars spin rapidly, emitting beams of radiation that sweep across the sky like cosmic lighthouses. These are known as pulsars. The journey of a neutron star begins with a massive star, at least 8 times the mass of our Sun. These stars spend millions of years burning nuclear fuel, fusing hydrogen into helium in their cores. As they evolve, they expand into red supergiants, and their cores continue to fuse heavier elements. Eventually, the core builds up iron, which cannot be fused to produce energy, leading to instability. This triggers a catastrophic collapse, followed by a supernova explosion that leaves behind a neutron star. The resulting neutron star has an intense magnetic field and gravity, creating extreme conditions unlike any other. So gravity is the architect of the universe. It is the force that draws matter together, forming stars, planets, and galaxies. Gravity also plays a crucial role in the creation of kilonovas. When 2 neutron stars are born close together, they are locked in a gravitational embrace. Over millions of years, their orbits decay. They spiral closer and closer, their speeds increasing as they approach their inevitable collision. As they draw near, the gravitational forces become extreme, distorting the fabric of space-time itself. This cosmic dance culminates in the explosive merger that creates a kilonova. Gravity not only shapes the large-scale structure of the universe, but also drives the most energetic events, like black hole mergers. It bends light around massive objects, creating phenomena like gravitational lensing. Gravity governs the formation and evolution of solar systems, ensuring planets orbit their stars. Even the expansion of the universe is influenced by gravity, as it competes with dark energy to shape the cosmos. In the beginning, the universe was a canvas of simplicity. It was painted mostly with hydrogen and helium, the lightest and most basic elements. The heavier elements, the ones that form our world and our very beings, were crafted later, within the blazing hearts of stars and the cataclysmic explosions of supernovae. Kilonovas are the master artisans in this cosmic workshop. The intense conditions of these stellar explosions forge elements heavier than iron, such as gold, platinum, and uranium. These precious elements are then scattered across the cosmos, seeding the birth of new stars and planetary systems, and ultimately the creation of life itself. Section 6, a cosmic mystery, why the emptiness? It seems counterintuitive that kilonovas, these incredibly powerful explosions, would occur in the desolate emptiness of intergalactic space. After all, neutron stars are born from the death of massive stars, and massive stars are found in galaxies. So why do kilonovas happen so far from the galactic mosh pit? Scientists believe that the answer lies in the violent kicks that neutron stars can receive during their birth in supernova explosions. These kicks can send neutron stars hurtling through space at incredible speeds, ejecting them from their parent galaxies and into the vast intergalactic void. This emptiness, this cosmic void, is not just a backdrop, but a stage where the most dramatic events unfold, far from the bustling galactic centers. In this isolation, the true power and beauty of kilonovas are revealed, untainted by the chaos of nearby stars and galaxies. The light from a kilonova takes billions of years to reach us, traversing the vast expanse of the cosmos. When we observe these distant events, we are peering into the ancient past, witnessing the grand tapestry of cosmic history unfold. Yet kilonovas are not merely relics of bygone eras. They are the echoes of creation itself, powerful reminders that the universe is a dynamic and ever-evolving masterpiece. The heavy elements forged in the heart of kilonovas are the building blocks of life, as we know it. The gold that adorns your jewelry, the platinum that powers your catalytic converter, and the uranium that fuels our nuclear power plants. All of these elements were birthed in the fiery crucibles of kilonovas, billions of years ago, in cataclysmic events that shaped the very fabric of our universe. Section 8. A Universe Intertwined. The study of kilonovas highlights the profound interconnectedness of the universe. These cosmic events, born from the collisions of neutron stars, release an immense amount of energy and create heavy elements like gold and platinum. These distant explosions, occurring in the vast emptiness of intergalactic space, have played a crucial role in shaping our own planet and our very existence. The elements forged in these cataclysmic events eventually find their way into new star systems, planets, and even life forms. The atoms in our bodies were once part of stars that lived and died long ago. Every breath we take, every element in our bodies has a cosmic origin. This profound connection to the universe is a reminder of our place in the grand tapestry of existence. We are, in a very real sense, stardust. The very iron in our blood, the calcium in our bones, and the oxygen we breathe were all formed in the hearts of ancient stars. As we continue to explore the universe, we will undoubtedly uncover even more wonders and mysteries. Each new discovery adds another piece to the puzzle, helping us understand the vast and intricate cosmos we inhabit. Kilonovas are just one example of the incredible phenomena that await our discovery, reminding us that the universe is a far stranger and more awe-inspiring place than we could ever have imagined. The more we learn, the more we realize how much there is still to discover, and how deeply interconnected everything truly is. In this grand cosmic dance, we find hope and inspiration. The universe, in all its vastness and mystery, is a testament to the beauty of interconnectedness. As we gaze at the stars, we are reminded that we are part of something much greater, a universe intertwined in ways we are only beginning to understand.